Γεια σας, είμαι ο Κωνσταντίνος Καπερώνης, ιδιοκτήτης της Golden Acoustics και αντιπρόσωπος της εταιρείας Kuzma. Είμαστε εδώ στο στούντιο αναφοράς της εταιρείας μας με προσκεκλημένο τον κύριο Frank Kuzma για να μας μιλήσει για όλη την ιστορία του και την ιστορία του αναλογικού και την επιρροή που έχει ασκήσει σε όλο αυτό τον κλάδο. Mr. Frank, welcome. Welcome to Greece, welcome to Athens, welcome to Golden Acoustics and our reference listening room.
Thank you very much, and I'm really pleased that you invite me, and I'm really enjoying being in this your beautiful listening room. Thank you very much.
It's an honor for us having you here. Thank you for being here.
Likewise. Hello, my name is Frank Kuzma. I'm coming from Kuzma company, where we produce analog turntables and tone amps, and I'm the chief designer and the owner of the company.
Thanks for coming. Welcome to Greece, to Golden Acoustics. Welcome to our grand listening room. And let's talk about turntables, about analog stuff.
Well, to me it's also a pleasure to come to Athens for the first time and see you have a really nice listening room with a lot of other products, and I'm proud that actually you present Kuzma products among the top other products in the world.
Thank you very much. So you started at about 1983?
Yes.
Yeah. The turntables of that age, Saline Sonde, Pink Triangle, they were not very technologically advanced. They were difficult to set up. There was that marketing myth about them, that they sounded good, that they were perfect for their age. Why was that?
Well, I think that if you go back to the mid-60s, when the audio research turntable came out in the market, it was the first turntable which was with light suspension. It was the original idea about turntables to be light suspended, isolated from the environmental, and it seems that it works and it played very well at the time. And so this then picked up through the 60s and 70s and 80s, when of course the Lim promoted this type of approach to the turntable design, and they've been very successful. And they've been followed by some other companies. And at the same time, it exists, of course, the other companies which we are less aware of it because we're not so much in the hi-fi media, from the EMT turntables we used in professional studios and other turntables. So we, as young audiophiles, we did not consider this as a serious turntable. Serious turntable, of course, the price was different, but the serious turntables was at that time was Lin and other companies. But they have all share something in common. They've been very popular, and they make them very difficult to set up. And it was very difficult to set up, or you've been never sure does the turntable play at your best. So you've been required to go to the dealer or to someone else to show you what you're doing wrong or not doing wrong. So when being mechanical engineer, I decided, like any machine, if you want to make precision cutting, it must stay up set. So therefore, I decided to make the turntable with the suspension, emphasizing that what adjustments are required. It will be there, and once they set up, they stay set up. And the same applies for the tone amp as well.
So what was Saline Sonde? What was the problem? In what ways should it be more technologically advanced? And what did you do to solve the problems, to make a better turntable? Because the Stabi was far better, and it stayed set up. Once set, it stayed set up.
Well, one of the approaches is that you look into the problems and try to solve them, or then make a better solution. And usually this costs more money, more material involved, or requires more manual approach to the turntables to be made. That it's maybe not possible to make it so mass-produced in the same way. And at the same time, if you take away from the customer setting up, you put into the picture the dealers, because the dealer became more important, which is nothing wrong with that, because most of the people, even today, still know how to set up a turntable or tone amp.
And in the Linsonde area, dealer was God. Yeah.
Indeed.
Yeah, clever marketing.
Especially
But not so clever sound.
Well, look, it was the best at the time. And also at the same time, of course, if you as a customer, you go to the dealer, since he is a god, he also says, buy this speaker, buy this amplifier, the cables are all just coming out, understands, etc., etc. So you get the whole spiel, so to speak, to go on.
So how was the first Stabi and Stogie born? What research did you do? What materials did you try?
Well, I will start from the names. The turntable's name is Stabi, which came from stability. And the word stability, we can...
I never thought of that.
Yeah, and the word stability can put it in more aspects than one. From the stable platform to play records, from the turntable to stay stable, not to be wobbly, to stay set up. And for the stogi, the word comes from, in Slovenian word for there was no understandable, so the stogi is Slovenian word for rigidity.
Okay.
So it comes out that the tona must be rigid, not flexible, and yet at the same time it requires certain movements across the record.
Yeah.
So this was the approach, and that time of course was necessary to set up certain things like horizontal level, suspension height, and with the tonam, the VTA, the azimuth, of course the tracking force, and you don't want that this change through the time.
Yeah. They were very advanced for their age. I mean, you were talking 1983.
Indeed.
Yeah.
But advanced, let's put it this way, our approach to design our products was always like a good machines for lathing or for doing mechanical products. And thus, such machine, if it's precise, it requires just that, to be stable through the production. You set it up, it must do what you want to do. So we feel it in the same way. If you want to listen to the record, we need that all other factors are removed in this chain of from the needle, cartridge, tube, tonam bearings, sub-chassis, turntable bearing, and platter to the record. This chain must be rigid, and the only movement should be between the cartridge body and the needle.
Well, I remember the first Stabi and Stogi that my father acquired from the old importer, Nikon Menthrinos, and I remember that once we set it up correctly, it stayed set up for years.
Yes, indeed.
That was, but at that age, that was not the case. I mean, we always tried to set the lean sounding, and after a week, again and again and again, oh my God, and it never played music because it was never set up correctly.
Of course, at some point, a bit later, we have a bit of a problem. You know, there was this stay set up all the time. It happened after 7-8 years that the counterweight stayed the same position on the tonam, being stuck with the grease, with the grease, not oil, and not with the country. So this was a problem. It stayed too on. There was some problem with the material and the combination of the material. We solved it, but so it stays so well all the time set up.
Let me ask you another question. In recent years, many of our customers who have seen a trend that a fixation. They want to fix their old vintage turntables instead of buying a brand new one, a cheap one, a Stabi. But they want to fix their old turntables. Why is that?
Well, if you're looking through the whole trend, especially now with the internet possibilities to find everything on it, people did discover that the old turntables, they were well made. Because if you go to the turntables like EMT, Lenko, all these, they've been very solidly built. They've been built to be used in the radio stations, they've been used to under serious thing, and this goes back that the design was already there at that time, before lean. And that time shows that these turntables have been designed properly. They've been not wobbly, they've been not with the certain aspects at that time which the certain turntables, it was not required. I would not go into that direction and say that, but certain aspects really must be taken in consideration when you're using EMT turntables, Lenkos with the idler drives, which are very good because they have this, first the structure is very good, so there'll be no wobbling there. And the drive on the platter is very good with the idler drive. It could be a bit of a problem in the context of using this turntable when you need really precise or very low Woman flutter when you're listening maybe to classical music. I mean, if you're listening maybe to rock music, it's not a problem at all.
Yeah.
But this must be taken in consideration.
So for the good ones, it is justified because they're good turntables coming from a good age. Yeah.
Like any product, everything is pluses and minuses. So it's just a question what you're looking into it.
There are manufacturers that make products, turntables, with huge price tags, like the Tech DS, the Japanese turntables, for $100,000. They cost more than a house or a car. Could you ever consider building a product like that? You know, what would you do? What would you consider to do?
Well, it's very simple. You know, we're using in our turntable, in the top products, we're using the ruby ball, which is about the size of 3 millimeters. And this is number 9 material. It's material just below the diamond. So we just changed this ruby ball, which costs in reality $5-6. We use the diamond ball of 3, it will cost $3,000. So we can make the turntable easily more expensive. But the friction is lower theoretically in the diamond than in ruby, and we need to try it if this will have any or not effect on the sound. If it will have effect on the sound, we will use it. If not, we will not.
So you say that these products with the upsell prices, some of them are justified, technologically speaking or material-wise?
Yes, I would say.
Maybe,
I would say. Look, if you look at the tech desk, they're using the air bearing, they're using the vacuum.
And this suspension.
And this doesn't come cheap. If you imagine the simple turntable, you cut a piece of wood, put the bearing in, put the tonum on it. It's simple. But if you put something sophisticated that it works in long term and doesn't break down, it can be into these problems which we say before. Why not? And of course, being the small production, this costs money. I mean, if you're looking at our top turntable, which is basically 90 kilos of aluminum and brass, and the price of a mid-price car, you can say this is absurd price. But small production has a different
Higher
cost.
the price,
Yes.
Okay. So shall we wait for the Excel DC Diamond edition?
Well,
Come on, you said it. You said
no,
diamond.
but let me say, if you use the diamond, there are options. You know, you can have diamond ball, or you can have a diamond coated ball. That will cost 1/10 of the price of that one. But there is more to it. You need to do other things as well to maybe increase the quality of the reproduction from the records by putting more things into it than just one little aspect. If you let me say, if you add to the turntable more sophisticated suspension, if you add, I mean, if you're just looking like this suspended table which we're using it under this turntable behind us, that's very special product. If you build it into a turntable, it will increase the price a lot, and it will have even a summon effect. But the price will go up.
Let's stick to that. Say you have an XLDC. You have an airline with an air bearing. Could we ever imagine an XLDC with that mass of the platter rotating on an air bearing, or do we must have a rigid mechanical connection between the platter and the shaft?
This rigid connection, it must be. But more important is not the rigid connection. More important, there is no movement, there is no distance movement. Because if you look in the XL turntable, the original design even, there was a platter standing on its own and the tonum tower standing on its own. There was no turntable in the market at that time with this so-called stupid idea. So I was considering what that means. There's no connection, which is good, because the vibration is not coming from one part to another one, despite being on some support platform, which of course it's a rigid connection at the end of the day. And if you have enough mass, the both parts will stay into relationship between each other without any problems. So theoretically speaking, they are connected because the distance stays the same, but
So
not
you say that
physical
with
connection.
an air bearing we will have wobble.
Well, the air bearings are problematic by itself. You need to make a rigid air bearing. If you make a floating bearing, that means that if it's a low pressure and big gap, this is like a spring between two parts. So it's a resonance and it moves. If you make a proper rigid bearing, like is used in the industry, when you use it in the top quality machines, it's high pressure, small gap, and this is the rigid connection. In our airline tonum, we're using 4 bars pressure, the gap is 5 microns, and actually you can use the force of 20 kilos and pull the tube along the cartridge, and we still maintain that gap, which means it's a rigid bearing that wouldn't be moved, the cartridge. If you imagine the bass came in the music, it pulls it along. So if it's elastic, you're losing that control. That's why a lot of times you read about the tonums, tangential tonums on the air bearing, that they're very, very good, but they have a bit of a problem playing the full spectrum.
So theoretically speaking, you could have a rigid air bearing that can support the mass of the platter, of the XL.
The air bearing can support more or less any mass.
Yes.
This is not a problem, it's a question of construction and
complexity?
Not really.
Cost?
The main problem is actually air supply. These costs. Reliable air supply.
Reliable supply.
Yes. Otherwise, but of course the air bearing you can make it again in a just simple floating version or a bit more rigid combination. And of course rigid bearing will cost a bit more money than
What do you mean floating or rigid? What's the difference?
Floating is very simple. If you go to the beach and you put this floating cushion on the beach to lie down, you throw yourself down. What's happened? Now that's to me floating bearing.
And the rigid?
Rigid will be that
Because
construction.
it will not touch.
You have a small gap,
Yeah.
high pressure, so there's no connection between metal
Metal to metal.
to metal,
Yeah.
and there's a 5 micron air gap between, which gives zero friction and zero movements. That's the difference.
So let's move to the car 60 behind us. The nice red cartridge. It is it is by our standards, maybe the best cartridge, moving coil cartridge in the world. Could you ever consider improving it? Other things to do better?
Well,
Other things to be improved? You said that everything can be improved.
indeed.
Yes, but
But I'm not exactly a cartridge constructor, so I'm not know exactly which way to go, because my design in this cartridge was involved in a similar way like making a speakers. I don't offend anyone who makes speakers because it's more complex because of the drivers and the crossovers.
are you talking about the metal body that does not resonate? Yeah.
Yes, but I did design the outer housing and inner housing, having in mind that this would be again rigid, solid with minimal vibration. And then in Japan, by my specifications, they pick up certain parts together, and the company who is involved in a lot of cartridge making, but I'm not at liberty to say which one.
So you say, okay.
It's not a company that is known as a
Yeah.
cartridge maker. They're making
Okay.
for a lot of other companies. So we put together a really nice product, and the results came out as an extremely well made
Nice,
cartridge.
magnificent product. It's only nice.
Even I like it.
And you're a difficult one. Okay.
Yes, it is a space to improve.
Yeah. Ah, there is.
But
okay.
we will see.
Always. In every product.
Exactly.
Yeah. Okay.
But this is in the long term.
What about the airline?
Airline was certainly an attempt to make the best tonam in the world, and we introduced it in 2004. And then we wanted to make the best pivoted tonam, and we introduced 4-point tonam with our unique bearing concept in 2008. And as we say before, you can always improve anything. And there are always ways to improve, but maybe not so much in the making the sound better directly, but maybe some more ergonomical things on the airline tonam, because maybe better way to bring down the tube, the wires, maybe changing the mass distribution, certain aspects, and one feature which is lacking, and that is, and the reason why it's lacking is because you want to keep structural rigidity really high. There is no horizontal leveling, which is mandatory to use the airline tonam. And maybe we'll tackle these two problems.
Yeah, we know that in action. I mean,
so maybe we'll introduce
faced it,
tackle, but as everything else, to change it requires time and money and energy.
One of the few turntable manufacturers that make all of the parts inside in your production facility. Is that absolutely necessary? Could you make some parts outsourced? Could that be a problem?
Well, it's a question how you organize your production.
Yeah.
For example, when we say that we're making it, it means that we order some parts to be made by outsourcing with some sophisticated CNC machines or even some more manual machines, but the parts don't come finished. They just finish to some level, and then we finish it in the house. So we keep all the control. Of course, we buy some parts like motors, like wires, this is logical. But if you have a good organization and good partners, no reason why I could not make it if they do it what you want to do. So I think that's not essential. But in a small manufacturing process, it's very difficult to find partners who will do the parts as you want them.
Yeah.
That's the most difficult part.
Quality control that matters most.
Yes.
Yeah.
For example, for us, when people ask us how long it takes you to assemble a 4-point tonam, I said to them, well, 2 years or about 4 hours. So they asked me why. Very simple. When all parts are in the house, then we need to assemble the tonam in these 4 or 5 hours. But it's 2 years preparation that all parts are done to that level to be just assembled.
Interesting.
Yes.
Very interesting about the process of making a new product or designing a new product.
Well, in the 4-point tonam it requires about 200 parts.
Wow.
Yes. And they all must be done before.
That doesn't show that way.
Well, when you put it apart, because a lot of parts, they're subparts, we put them together.
Yeah.
We assemble them into, you don't see that it's assembled from various parts. And some reasons are because of the construction, some reasons are for the reason, like our structural rigidity, damping, etc., etc. And some parts are just because that's the only way to do it like that.
What aspect of a turntable tone arm do you consider the most important for accurate reproduction? Is there just one? Can you name just one?
Well, I think that early in this interview I mentioned this circle from cartridge body to the tone arm bearings, all this chain via the subchassis and to the turntable bearing to the platter. This chain must be unbroken. And this is the most important.
Mechanically speaking.
Yes.
Yeah,
and then is a question how you do it.
understand.
Of course, the other aspect, of course, then the time. Time means platter rotation. That's another matter. That's very
Speed
essential.
accuracy, you mean?
No, it's not speed accuracy, but it's more of a. One is the turntable rotates, platter rotates at 33 RPM per minute. That's an average speed. And let me say, if you take the aspect of the stretching that we looked at 1,000th of a second of a time frame, in this 1,000 seconds the speed must be as average as possible. So it doesn't matter. Theoretically speaking, in 1 minute, platter could rotate 35, 32, and average is 33. So, but in this short period of time, must be average speed all the time. Because if you imagine, if it comes a bit of a speed up and down at the beginning of a transient of a note, it will smear it. Now it could be because of the fluctuation of speed, or it could just be the needle who puts energy on the groove slows down for that fraction of a time the record rotation. So again losing this transient. At the same time, it's a stress on the bearings of the tone arm, and this can cause again this smearing of a transient.
Tell me again the mechanical path from a bearing, from the cantilever to?
Let's put it this way. You have needle and the groove in the record. So you have a needle, you have a cartridge body, you have a tube. In the tone arm, you have a tube bearings. Tone arm is fixed on some chassis. Then on the same chassis is fixed the platter bearing. They have a platter, a mat and a record, and the groove in the record. So this chain must be unbroken, plus the timing.
Unbroken, yes.
Plus correct timing.
Plus correct timing,
Plus not that the disturbances from the outsource are not coming. But if you go to what is causing the problem, you have a cartridge vibration body, you have a tube vibration, you have slack in the bearings, you have vibration in the bearings, you have chassis when you knock
chaotic,
it. If you knock the chassis, that it vibrates. And then you go to the slack in the bearings. They have a platter, noise in the bearing of the platter itself vibrating, the mat vibrating, and the record vibrating. I'm surprised we can actually hear any music.
I'm anxious.
Well, and then
hearing all this.
And then if you compare it, that you need to make the record with all this process of making record. And at the same time, I have a few tape recorders, master tape recorders, and I'm listening to the original master tape and the record.
It's a miracle that the sound comes through,
It's a miracle it comes that close.
So good, and it comes so close,
It's a miracle.
So do you think, have it just behind us, that the huge mass of the XLDC is enough to stop any vibration coming from the air, from the rack, from the speakers?
Well, the mass itself doesn't solve any problem. The mass itself in the turntable solves or minimizes a problem. If you knock on the platter, it will not vibrate, and gives a bigger rotational mass to keep the average speed and the small fluctuation to be even. But the problem is, if you don't put enough power on the heavy platter, it will go up and down. It's like trying to pull the caravan with the adequate strong car. It pulls them back, so you get the movements. So you have to this problem. So the certain mass of platter requires certain power that is even all the time coming on the platter. When we say power, we mean the rotational momentum.
Doesn't mass stop, absorb, or diffract? I don't know what term to use. The noise coming from the speakers from the room.
Well,
I think here is the part that zero vibes comes in.
Well, we have a few vibrations, or let me say, a few noises coming on the record. Let me say, one is the bearing, which I think is in good design bearing, is quite small. Second is movements in the bearing, which can move the whole platter on the record, which is another movement. Then we have the structural noise from the speakers, from the environmental coming on it. And we have actually probably the most influential is the noise from the motor itself. Because via the motor, vibration in the motor are transmitted via the belt on the platter. So we use normally rubber belt, which hopefully filters a bit these noises from the motor on the platter. But at the same time, we are losing also the momentum of the platter. So you need to find a good compromise between the rigidity of the belt and the motor noise, and enough power bringing on the platter, because as I said before, if you're pulling the caravan, you want that the motor is not pulling platter back and forth. And here even 50 kilo heavy platter will not help if you don't bring the power in it. At that moment it stops slowing down, little, but it does.
So regarding the noise, I think the best solution is to use a heavy turntable like the XLDC on the zero vibe.
Well, the zero vibe is certainly a very sophisticated piece of equipment. It's designed that the electronic microscopes are not getting vibration coming onto this very, very large magnification. Certainly it filters all minute vibrations. It's the earth itself. It's in the constant vibration, constant movements. They have the traffic, trucks, everything moves.
Building noise,
Everything. So this filters quite effectively out this noise. Of course, we don't know what it means, because most people could not try having zero vibe, for example, under all components. And then you see how it sounds, the system, when you try it under all components. One is the turntable, one is the preamplifier, power amp, everything. So we need to try with about 10 pieces of zero vibe.
Yeah, on the XLDC, the difference was astonishing. I mean, it was like having a camera and having the lens out of focus, and then when you turn it on, it focused everything.
Yeah.
But we were just imagining, what if I had a zero vibe under the preamp, under the phono stage, under the amps?
The same effect.
Under the speakers.
The problem is with the speakers, because they are
very
itself.
heavy. Yeah.
No, not just heavy, but they have this problem that they create a lot of vibration. The
And
housing creates.
could you handle it?
So it's a problem what you do with that, because this
It
will
would
not
lock,
eliminate.
Yeah.
Because it will filter just vibration from us. It could be.
I think it's Costa's next dream to have zero vibe under every component in the system.
Well, we did try it under the preamp.
Yeah.
And it was
Must be
similar
interesting,
effect, yes.
Similar effect,
Yeah.
So about the materials you use in platters, plexiglass or with aluminum, have you ever considered using other materials? Would it be better or more expensive or more difficult to manufacture?
Well, there is always that I can see improvement in turntables to using different materials, definitely. Then we are with what's possible to get, what's possible to machine, and what will be actual improvement in actual as an end result.
Yeah.
And certainly I would like to play with different materials. And we did some experiments with the graphite platters, maybe more or less as a mats and that. But
interesting.
But there is always this, one is using material, one is how to use it. And if you look at our platters, they all construction from multi-layer materials, because if you use, let me say, one thick aluminum plate and you knock it, it will vibrate. You put
like a bell.
You put half the thickness, two plates together, aluminum, put them together with the force, they will not vibrate at all. So what is better? So it's also how to use material.
So concerning audio racks, what do you think makes an audio rack? What are your own requirements? What do you use at home, let's say it like that?
Well, I do believe that actually the rack need to hold components still. And then is a question of a bit of a damping vibrations coming, for example, from environmental or from one component to another one. So what to do? Let me say you have a transformer in power amp, vibrates by itself, the transformer vibrates the component itself, and then vibration are coming maybe to preamplifier.
Yeah.
So maybe it's good that
the other
components. So maybe it's good that the preamp is then bit insulated, that filters vibration coming from the other components. So it's a question, I would say, rigidity, and each shelf on its own should be a bit of doing some filtering of vibration coming from the outside, or not going into the other components. Probably that's the best way to go.
It is a comparison between the current generation of XLDC with an DC motor and the older generation with 4AC motors. Why did you change it? What was the difference? Was it measurable? Was it speed stability, low and flatter? Better sound?
As I said before in one of the previous questions, that what's important is if you look in this 1,000th, for example, 1,000th of a second of a time frame, that is at that time all the time energy on the platter rotation. And with the DC motor, but not any DC motor, it must be powerful with a lot of energy on it. That at that moment is all the time energy on it. And we cannot do that with the soft rubber belt, because AC motor was noisier than DC motor. So we need to have softer belt to bring the momentum of rotation on the platter with DC motor, but powerful to bring the momentum of rotation on the platter at all the time in this short time period to be all the time energy in the platter. Okay. For example, I will give you an example of a experiment. I do have actually a turntable version of axle with the air bearing, and has a 50 kilo heavy platter.
A prototype, you mean?
Yes.
Okay.
And you take the belt off and you rotate the platter with the hand to approximately 33 RPM per minute.
Yeah.
And then it slows down because nothing is there except the air around it. And it takes about, should I ask you? Will you guess?
No, tell me.
Okay, 30 hours approximately that the platter completely stops.
Come on.
So this is, so it's very...
30 hours?
30 hours, which is meaning slowing it down purely that friction in the air bearing. And
which is nothing.
Which is nothing, but yet it is something. It stops down because as will turn...
Otherwise it will go on forever, yeah.
Yes, so. But then I put the record on, and I put the needle in the groove,
and it stops.
And rotating it to the same speed and let it go how long it takes to stop the platter rotation, only the needle. And it stops in about 10 minutes.
Yeah, because the cartridge
which is shocking.
Stops. Yeah,
so you can see that the needle breaks down the speed or rotation of the platter quite with a lot of force.
Yeah.
Now we stretch this to this 1,000th of a second as an example. You can see there is a lot of things happening there with energy, slowing it down, slowing it up. And so therefore, bringing the energy on the platter all the time. That's why it's a problem if you have a, this is of course my opinion, you have a heavy platter with a minimum power of motor, like minimum vibrations coming in the platter. And usually the end result, they don't perform well under the complex music.
And this prototype is something like an XLDC with an air bearing, I presume.
It's a version that we experimented with air bearing for future. But the main reason to go for the air bearing wasn't less noise in the bearing, but higher rotational mass to see what does it do.
So in your future plans, maybe we will see a new model with an air bearing.
Well, of course, you said that we need to make more expensive turntable, isn't it? So
this will be the XLDC Mark II?
I don't know. We already have a problem. If we call it XLR, it's confusing in English because you say XLR or air like a Stabi-R. So it's a bit of a confusion. So you must find a different name than air. This is still quite in the future.
Yeah. Along with the Airline 2 and the Car 70.
Yeah. CR70, yeah.
I think you're dreaming of a Car 70.
Well, look, you need to be always ahead,
dreaming
of course.
Better new products,
No, but I think it's very important that you don't change the product just like that for sake of it. It needs to be, if it's a change, it should be a serious change and not in short period of time. It must be after some time.
Well, when new products come out of Kuzma, we'll lose our sleep about the improvements, and now it will take me many days to settle.
Well, if you're looking at the portfolio, we do make new products, but don't stop making old products.
Yeah, from all the kinds of noise coming in the table from mechanical contact, which is the most destructive? Which is the one you need to combat, you need to invent maybe new technologies, new materials? The noise from the platter rotating on the shaft, the noise from the cantilever tracking the grooves, the noise from the tonal bearings?
I think that the most important is to keep the cartridge body still.
Not vibrating, yeah.
Because then the needle via cantilever and the coils, if it's an MC cartridge and the magnet, will read only what's there. Of course, then you have outside vibrations, but if you don't keep the cartridge body still, it doesn't help you anything else.
How can you keep it still?
I don't know. By having a good construction of the tonam and the rest, etc., becoming able to do this circle. So
everything, same circle again, the mechanical circle,
and everything will affect it. Everything affects it. So it's not just one thing. So try to keep everything to minimum. That gives the best results. If you eliminate one, it doesn't help you because you have something else coming on to cause a problem. I mean, for example, you can, let me say, if you're talking about the vibration in the tube, that you can hear the noise if you put the stethoscope on it.
On the
tube, yes, you will hear the noise. Fine. Then you say, is this good or bad?
You will hear noise or the music?
You will hear music,
You will hear the music
with the delay, How about if I made the rubber tube? You will hear nothing, isn't it? No.
Presumably, yeah.
Exactly. So what is better tube? That one you can hear nothing, and then you can hear something. You can think further, what will keep the cartridge more steady, rubber tube or metal tube?
I understand. Yeah.
So, compromise.
And about finding the best compromise.
Exactly.
And which one is that? Yeah, years and years of experiments and listening. Okay. Okay, let's talk about shafts. I mean, the line shaft, it's a work of art. How did you come up with it?
The shaft for the bearing, the approach which we have is this, to have the smoothest surface possible.
Yeah.
That doesn't mean that the smoothest surface, when you're looking at it visually, is that on which looks like a mirror. But it's important that you use the metal steel variation, which has a very, very small grain, because metal construction is in various, when I say grain, I mean crystals.
Yeah, the crystallic structure, yeah.
So the best is that these small crystals in it, and these are not usually stainless steel. So you need to use the carbon steel, which is used in the best knives for the same reason. Small crystal structure, you can easily polish it into the surface that is smooth. And then yet, as I say, that doesn't mean automatically the mirror polish. And it looks maybe matte, but if you look under the microscope to see these small ridges, they are more even. And actually, we do the normal machining of the shaft by lathing and then hardening, and then we do the grinding. But the final surface is done with the diamond polish and pear wood.
Pear wood?
Yes,
Wow.
you put the diamond polish on the pear wood, and then you touch the top surface to finish it off. But then we acquire a machine which has a diamond wheel, which do the final finishing of the surface of the shafts.
And how are the holes made?
Sorry?
The holes in the shaft? The holes that the air comes out?
Well, then you have the bearing, the outer bearing, you have rings.
Yeah.
Let's call it the rings. They are made to the certain precision, and we don't use metal rings. We use sort of a resin material, which is difficult to machine to the precision because it's softer material.
Yeah.
But we prefer this surface because it keeps the oil between the shaft surface and the ring, and also there is no metal to metal contact, which we believe is less vibration.
Yeah, it will be vibrating metal to metal. It will be that clanky sound.
Yes.
Yeah. So you use resin. Okay.
So that's the combination of bearing. The same we use it for the truss bearing for vertical. We use the same material, but between the metal shaft and this resin material, it's in the top of our bearings is the ruby ball made from the ruby.
How difficult was it to make it a commercial product? Because other manufacturers, I will not name them, have tried to do a good parallel tracking and aligned on arm, and they failed. They failed to come out with a commercial product. They're still in prototype mode.
Well, there was a few manufacturers in past who make actually, we call it properly made tangential toners with the properly used air bearings, which means they use high pressure air bearings. If you go to the back from the Rockport, from some other tables, there was, from my point, this was properly designed tonams. Again, we go to the same thing, structural rigidity. Air bearing must be rigid. Otherwise, if it's air bearing with low pressure and big gap, it's like having tonam hanging on the string. If I have tonam hanging on the string, and the groove, energetic groove comes to the needle, it pulls the cartridge along. Therefore, the cartridge body is not stable, and you're losing the information, or smearing the time information must be done. If you imagine the normal tonam, it's fixed in the pivot, it's not pulled along. But of course, the pivot has its own vibration, so again, this vibration from the pivot or any other bearing again affects the cartridge platform.
Okay. And the same with the shaft on turntables. I mean, the inverted bearing with the ruby ball. How did you come up with this? How did you design it? What was the process?
Well, there are certain solutions known for years in mechanical engineering in industry and other places, so it's not exactly nothing new as such, but it is a bit of a problem.
It's not common in many turntables. Yeah.
It's not common, and it's not so much used in such heavy loads. That's a bit of a problem.
Yeah.
Because if you're using a light load, it's not a problem using such bearing, but if you're using high load, it's a main problem that the oil comes between the surfaces of ruby and the surface of the material. So therefore, this is the problem, how to solve that, and what oils you use. Did you keep these surfaces lubricated?
How difficult was it to come up with the design? I mean, did you have many prototypes?
Well, it was like this. We made a solution, and it was working for years, and suddenly it happened things didn't work anymore because of the environmental and eco. Certain companies start changing materials to get rid of certain materials which used to be built in without telling anybody, It's still the same material, same specifications.
But they changed it. Yeah.
But they changed it, and before, when we accept that certain things were under the edge of the possibility to use, suddenly it was not possible.
Yeah.
It was the same with the resin material, it was the same with the glues. They're not anymore that strong, but they're just okay strong. And this resin material was okay, but wasn't that strong. I'm simplifying, but just a concept.
Yeah, I understand.
They were still in the border, but we used it to the extreme, so suddenly we came out of this extremes. We have a bit of a problem, so we solved them then in a different way.
Let's talk about the XLDC. Interesting question that Kostas reminded me of. The power supply of the XLDC, the way that the servo talks to the platter and takes the info back.
No. It talks to the motor itself. In the motor itself is built-in electronics which controls the motor rotation.
So it takes info from the platter rotating?
No, just from the motor itself.
From the motor?
Yes. Motor itself has built-in the controller which controls the speed, because it's a DC motor, and electronics in the motor and outside electronic controls the speed of a motor via the frequency, not via the voltage. Normal DC motor speed is controlled by the voltage, and this is of course very sensitive.
Yeah.
But this DC motor which we're using, it's controlled by the frequency, therefore is more stable, and also of course it's low ripple and all these three-phase. But
yeah, and it's absolutely essential to keep the rotation stability.
Exactly.
I mean, the XLDC power supply could not be that good without the servo mechanism.
It's all together one unit. The good power supply controlling certain aspects of the motor. A motor itself has its own electronics, but you need to bring certain information and power to these electronics.
We didn't talk about the new product, the Stabi-R, which the clients will see at the store on Tuesday. That has a built-in DC power supply, and we have some clients asking us, how can it be good if the power supply, the DC power supply, is included, is in the base of the turntable? I mean, how does it compare the new model, the Stabi-R, to the Stabi-M, to the Ref2 with external power supplies?
Let's go from the beginning. So we first introduce this, we call it DC drive, which consists from this motor, power supply, and a special stiff belt, which we say before it brings this uniform momentum on the platter rotation.
Yeah.
So the results were so good that we decided to bring this into the top turntable. So we changed AC motors for DC motors with this complete drive to the XL DC motor.
Okay.
One of the main problems with developing this drive was the noise from the motor, because it's a very noisy motor, in a different way noise, not vibration, but noise. Therefore, if you want to get rid of it, you need to encapsulate the motor in some sort of a damping material. When you do that, the stator of the motor, it's moving. Therefore, the rotor, when it should accurately rotate, sees the stator moving, and you get not accurate drive from the rotor out.
I understand.
So therefore, it's best to keep the motor rigid. But if you keep the motor rigid, you have a noise. So a solution was required, and it was done like this. We use some damping material, we use inner brass cups, and double insulation and triple insulation, and after 2 years of development and research, we did manage a solution for the M turntable.
So which one was the first to receive the DC motor?
Stabi-M,
the Stabi-M,
as a new product at that time.
And then the XL?
And then we said, okay, so we now learn, after 2 years of this problem, keeping the drive from the motor on the platter stable, we'll just do the same thing to the XL DC.
Yeah. And then to the Ref2.
Simple. We just copied the solution.
Yes.
It didn't work. It requires another year or so to solve the problem for the XL DC.
Wow.
This was a shocker to us at that time. Why this
Me
doesn't
too.
work? So therefore, we learned 2 ways to solve the problem. They're similar in construction, but just another didn't work. For example, just a little story. You have an open motor on the top, and it has a certain amount of noise coming out. You cover it with a thick brass plate to be less noise.
Yeah.
Not true, it was more noise.
More noise.
Exactly, a shocker. You know, why? Anyway, so then we decided, can we disk drive, because we believe that was really superior to anything else. We believe that was disk drive better than, was the best solution for the belt drive, was better solution than the idler drive, and was better solution than the direct drive. We think that this is the best combination of a drive for the platter.
And then the Rev also got the DC
So we
motor,
decided, can we bring this to the cheaper turntable?
Mm-hmm.
So we started designing Stabi-R turntable with actually AC motor.
Ah,
But it was just an idea. Then he said, let's bring this drive because it's so much superior to this level
yeah.
of a price range. And we thought if we somehow do some compromises, but of course the noise motor does not allow you to make much compromises. So we decided to do it with the power supply, they're putting in internally, avoiding the...
How did you put it? How didn't you use the external power supply?
Because it
You
will be too
always do.
expensive.
Ah,
It will be too
it
expensive.
It had to do with the cost, yeah.
Yes, we decided let's build it in if we can do it. So we build it in using the part of a structure of the turntable itself as a housing
Yeah.
and few other things. So we managed to bring the price down. We done some simplification on the power supply because it's not such a heavy platter.
And it is as good as the DC supplies in the DC motors and supplies in the other turntables, but it's
We
built in.
believe there was no down compromise on any
yeah.
drive for the platter because the XL is using 24 kilos, M is using 12 kilos, and the R is using 8 kilos platter. So
you managed to do.
we managed to do it, and I think that the result speaks for themselves. It's a very
Yeah.
good turntable.
So in the current line, where does the Stabi-R stand? Where
We sell our turntables by the kilos. So
No, come on. You have a price range.
yes, look, it is slightly more expensive than the Stabi reference, but the Stabi reference has a suspension.
Yeah.
So you cannot directly compare it because it will behave in a bit differently in a different environmentals.
Yeah.
And I'm not that person who say what's best. This must people find out by themselves.
So for a client, maybe the Stabi, the Ref2 will be better because he will need the suspension because of his system, of his room, of his floor.
Yes and no, because Stabi-R being such a compact, rigid structure,
Yeah.
basically is a big piece of aluminum, if I say it, made from one piece. So it's very non-sensitive on any vibration from outside.
Yeah. I remember when you first introduced it, you compared it to the Stabi-M. Price versus performance.
Well, the basic concept is, I mean, the drive is from the M or from XL, and the platter and the bearing is from the reference turntable. And Stabi-M also is sharing the bearing from the reference turntable. So there are some similarities there, and therefore you have some things which are similar. And through the time you learn what's more important, what's less important.
So it is a lot of Stabi-M for less money.
Exactly.
Yeah. And it's a nice thing that you can do the thing with other versions, the thing you can do with all the different tone arms. You can even put 4. How did you come up with this? Who will need 4 tone arms?
Well, people who has 4 tone arms.
Come on, who has 4 tone arms?
Well, you can have like this. There are people who likes to play around. For example, some people like mono records.
2 tone arms are their turns.
Yes.
Yeah.
And maybe you have a different ones. You can put on different ones. You try to play. Maybe you can have one tone arm for 6 months, then other 3 months you want to try another one, you know.
Yeah.
It's an option. If you want it, you can have it. No need to. So it's just an
Yeah.
option because...
I read a good review in Hi-Fi Plus, but they said it's a good transcription turntable.
The idea behind was
Yeah.
that we offer on the market the turntable, which before I mentioned has the benefits of all drive from our point of view, to be used even instead of the old turntables like Lenkos, like AMTs, because it's such a construction. You can build it in your own plinth.
Yeah.
You can make your own wooden big block of, around whatever you want to. So you can really play around with it. You have your own turntable with your own visual and construction
I mean, the
ideas.
customer can build his own.
Yes.
Yeah.
You just build it in, fix it down, and that's it. You can put it. We've been at Munich show. When people ask us, "What do you suggest as a, what sort of a wooden structure?"
Like they do with the old guards.
Yes.
Yeah.
So I said to people, the best solution is to use 1 by 1 by 1 meter big block of wood and cut it in on the top.
Come on.
And if you want to prefer it, you can have 1 by 1 meter and 2 meters. Have little ladder to climb on the top, if you want to, or a bit smaller. It's up to the customer. Because we provide, it's not on internet, but we'll provide the basic measurements which you need to cut out, to fit in, and then you can really do up to yourself what you want to do.
They can do whatever they want. They can change tournaments, they can change
Exactly.
cartridges, they can use different cartridges for classical music, different for mono recordings, different on arms, That's why they call it transcription turntable in the review, because you will hear what is the groove, what is in the groove. Nothing more, nothing less.
Well,
And not to break the bank.
well, in principle, our job is to bring what's in the grooves. So even
In every model, in every model.
of course, we always run to a question, you know, let me say, if you listen to classical music, should you hear it what is in the groove, or should you hear it how it sounds in the concert hall? Not necessarily the same thing. For example, of course, you don't want to listen it more aggressive than it is in the concert hall. But if you imagine when they record the classical music in the hall, the microphones are much closer to the orchestra. So the sound is brighter.
Yeah.
Now, what do we want? We want brighter sound from the record. We want a bit more normal as it's in the hall. Where we do this? With the speakers, electronics, cables, where we cut down that brightness. I just use it as a phrase. To have the right sound. Personally, my job is to bring as much as accurate signal to the electronics.
So far, how has it been received by the public, by customers, by your orders, or is it too soon to say?
Well, it is, in one way, it's too soon to
Stabi-R,
say.
I mean, the
Stabi-R, we just introduced it in September, and we did ship it to our distributors that they can show it to the shows, to give it to some magazines reviews, and we have a very, very good results back. Of course, we ran out of the first turntables, and hoping by the end of this year, we'll have a normal delivery time.
Yeah. So it's sold out, basically.
So to speak.
Yeah. So it is a success. Okay, Frank, thank you very much. Thank you for all the questions you answered. The ones I wrote and the ones I didn't think, but you answered them anyway. And thanks for having you here in Greece in our listening room. For coming.
Well, thank you for talking to me, and thank you for having me here, and I enjoy our conversation. Thank you.
Thanks a lot.